And then, so I give you $20. You have your like preconceived notion of how much change I'm going to give back to you. Is everybody with me? Okay, so we're starting kind of like, when we're thinking through this, we kind of have this like starting amount we expect, right? So some sort of initial expectation. And then we got to decide if the right amount of change we got back is correct. So for example, would you guys be surprised? It sure is, sorry. All right, would you be surprised if the change I gave you back after I go buy you a candy bar with a $20 bill, would you be surprised to get $18.09 back? Is that a surprising amount back? For like not like the extra large, just like a regular size candy bar. Would that be surprising? When you say yes, you think that's more change or less change than you would expect to get back?
Never mind, I didn't see that.
This is the change I'm giving back to you.
Yeah.
Everybody good? Okay. What if I gave you $17.57 back? Would that be surprising? Okay, so this is not surprising, not surprising. What if I gave you $5 back? Would that be surprising? Yeah. Okay. What about $8.78 back? Would that surprise you? $12.27? That would be kind of surprising. Unless you ask me for like one of those Dubai chocolate bars that I've not tried. Have any of you guys tried that Dubai chocolate that's supposed to be super fancy? Is it good? Is it worth the price? Because it's really expensive.
It's honestly, there are a lot of different things that are like trying to be quote unquote Dubai chocolate, and it's like really, really hit or miss.
Fair enough.
So to find one, like try to ask about other people, like there's probably like one right now that are finding those. They are stupid. I've seen $12.
Yeah, like, and not very big pieces of it are like $12. It's kind of crazy. Okay, what if I gave you $19 back? Would that be surprising?
Yeah.
I think that would surprise me, even though it would surprise me in the other direction. But that would be, what about $14 back?
If you went to an expensive grocery store, sure.
This one's, can I call this one a little bit more questionable? Is it, you guys with me? Okay. So we could like kind of think this through of like, we would have this maybe, if I asked you guys to estimate what is the mean cost of a candy bar.
$4? $3?
$3, $4.
But some of them are really expensive, so that would.
Yeah. Like, and where I go, right? Like if I go to Speedway, is it cheaper than if I go to Giant Eagle versus Walgreens versus CVS or wherever I'm going to buy these things, right?
It's usually more expensive at gas stations
Because they're trying to get people on the way through, right? So, or if I go to Giant Eagle and I get like the 4-pack of like Snickers or something, that's a little bit less expensive maybe per Snickers. You guys catch my drift here, yeah? Okay. So we might have some sort of average guess. I'm going to put $2.47. I'm making that up, okay? And then if we all go out and go buy candy bars, and when all of a sudden we're finding that we're getting a different, and we take a sample mean and we get a different one, let's say we get a mean of 279, that might make us question, was this original claim true? Is everybody with me? Okay, so when we talk about what we're going to do next, and we take this sample, what our goal in Unit 8 is going to be, does my sample give me enough evidence to say somebody's claim is wrong? That's the goal. When I get a sample that's different from what I would expect, am I allowed to call a claim incorrect?
Not necessarily.
Well, it depends. Right. So what we're going to learn is the statistical process to decide, does my sample let me say my claim is incorrect or not? Okay. So all right. So there's technically two different methods that we can have to run what we call a test of significance, okay? Both methods will have a state hypotheses. When we write our hypotheses, we write them as HO and HA, okay? We call HO our null hypothesis. We call HA our alternative hypothesis. Our claim, whatever it might be, is going to be in one of these two hypotheses, okay? Our null hypothesis will be, our hypotheses are either about P or mu. Just like we did confidence intervals for proportions and confidence intervals for means, our hypotheses are going to be about proportions or means, okay? Our null hypothesis will have a sign in it that is equal to, that is greater than or equal to, or is less than or equal to. All right. Our alternative hypothesis, same, will be P and mu, and will be the opposite of whatever I put in the null. So if my null hypothesis is equal to, my alternative hypothesis is not equal to. If my null hypothesis is greater than or equal to, my alternative hypothesis would be strictly less than. If my null hypothesis is less than or equal to, my alternative would be strictly greater than. So what I want to point out, because the first thing you're going to do is say, all right, my two hypotheses, whichever one has an equal to, that's the one that goes in the null hypothesis. Okay? All right. The next thing you are going to do is sketch a sampling distribution. You guys, your sampling distribution is either going to be a Z distribution or a T distribution. And the way you decide is it a Z versus a T is identical to the same way we did that for confidence intervals, okay? So it will be a Z if we're trying to make a conclusion about proportions, or if it's means, I know sigma. T will only be used for when we don't know sigma. It'll only be used for means. That part hasn't changed, okay? On our sampling distributions, we're going to shade a section of the graph, okay? The way I determine where and how I shade is my alternative hypothesis and what we call a significance level. A symbol for the significance level is the Greek A alpha. Okay, so I might write it like this, or I might say a level of significance, okay? This will make a whole lot more sense when we go through this, but this is going to be the general form for each thing, okay? When I do that shading, I'm going to create something called a rejection region. If you abbreviate rejection region RR, that will be fine, okay? All right, Your test statistic will either be Z or T. I'm going to show you how to calculate those, okay? And what you're going to basically, if your test statistic is a Z, it'll be shaded on this picture. If it's in the shaded region that we call this rejection region, we're saying that my sample is far enough away from what I expected that I'm going to say that null hypothesis isn't true. Okay? If it's not in the rejection region, then we can't say that. We're going to say that the null hypothesis is reasonable to assume the null hypothesis could be true. Okay?
Will you systematically? Okay.
Lastly, to make your conclusion, you're either going to reject my null hypothesis, that would mean that the alternative hypothesis is true, okay? Or you fail to reject, if we fail to reject, we're going to say it's reasonable that the null could be true. Now, there's a lot here, okay? I know that there's a lot here. I have tons of examples to kind of take you through. We will be following this process for units 8, and then test number 4, that's units 9, 10, and 11, similar process. We're going to keep following that process, okay? So this is the traditional method. When we get to the p-value method, I'll teach you how to do that part too, okay? All right, so let's go ahead and read this real quick. A manufacturer of computer chips claims a defective rate of at most 2%. Okay, so here's what I need us to see when I read that. Okay, when I read at most 2%, first of all, that is talking about a proportion. And my variable here is the chip defective or not? It is a qualitative variable, binary variable, arguably, okay? And what does the phrase at most mean if I had to translate that into mathematical symbols? Less than or equal to. And 2% is 0.02. We'll pretend I've been doing percents and decimals since I was, a long time ago. We'll just say. We won't say how many years, but it's been a lot. Okay. Which means that's one of my hypotheses. My other hypothesis is going to be the exact opposite of that. Okay? So now, as I go to decide which one is my null and which one is my alternative, my null hypothesis will be p is less than or equal to 0.02. My alternative hypothesis is that p is greater than 0.02. All right. The next thing I'm going to ask you to do is state where is the claim. This is the company's claim is the at most 2%, yeah? So I would say the claim in this case is in my alternative hypothesis. It's not always in the alternative hypothesis. In this case, it is. Okay?
Doing the null?
Yes, I meant null. Did I say alternative? I meant null. Are we good? All right. So the next thing I'm going to do is I've got to sketch my sampling distribution. And then I have to decide, am I sketching the Z distribution or the T distribution? Because this is proportions, it is automatically Z. Proportions are automatically Z. All right. A radio company takes a random sample of 500 chips, finds that 23 are defective, and I say 10% level of significance. That would mean alpha equals 10%. Okay. That's a lot. It's a lot of information. Okay. If this is a z, I know my standard deviation is 1. My alpha being 10% means I'm going to shade 10% of the graph. So the question is, which 10% do I shade? And the way we make that decision is we shade whichever my alternative hypothesis is. So if my alternative hypothesis is greater than, are you guys with me that greater than is on the right side of the graph? So I want to shade 10% on the right side of the graph. And I'm going to label this as 10%. This is me sketching the sampling distribution, and the shaded part here is my rejection region. Everybody good? Now, can I figure out this value right here? Can we figure out what belongs right here? 0.02. It is not 0.02. I would say that this area is 0.9. I'm going to use inverse norm. It's the same picture I've used for inverse norm for a long time, yeah? Okay, so if I put this into inverse norm, I'm putting in 0.9 because my calculator only thinks in left side area. I find that this value is 1.282.
Right,
82. Finn, why don't you move closer so that you can actually see?
Well, usually I'm able to get most of it.
Okay, so here's the deal. We will then find a z-score that's, so this is a theoretical boundary between which samples am I willing to reject this claim, say this company is lying, and which samples am I not. And when I look at this picture, essentially I'm going to reject any samples that are more than 1.28 standard deviations above the mean when my mean is the 0.02. That's what this means, okay? So what we're going to do is calculate the z-score of our sample. I've got great news. You don't need to memorize how to calculate the z-score of your sample. It's on your formula sheet, which I had up here at one point. It should say p hat minus p over the square root of pq over n, I think. It's right down here, okay? All right. So if I'm doing that in this setting, my p hat is 23 out of 500, which, by the way, I just worked, is 0.046. So to find the z of my sample, I'm going to put 0.046 minus, and this is where that 0.2 comes into play, or 0.02 comes into play. What am I assuming to be true? That 2% over just filling in the p of 0.02, q Q then would be 1 minus that 0.02. So not what is not 2%, it's 98% over my sample size.
You said Q was 98.
0.98.
Point, yeah. 98%.
Yep. Okay. So we found, so this is the Z of our sample. Where does it fit on this graph? In or out of the rejection region?
And
It's inside, very inside the rejection region, yeah? Okay. So if it's in the rejection region, we're going to reject. When we reject, you guys, again, we reject the null. Okay? And my reasoning is 4.153 is bigger than that 1.282. Okay, I'm going to compare it to this boundary. Is everybody good? So what does this mean? My sample, so because the whole process is, all right, my sample is 4.5%, 4.6% that were defective, right? That might make me question this claim, right? But is this sample large because samples aren't perfect, or is it large because the claim is incorrect? That's what this test does, is it makes our decision of how do I decide how weird this needs to be compared to this? And the answer is we don't decide, we let this number compared to this number make the decision for us. Okay? So, to make your conclusion in the context of the claim, I would say more than 2% of chips are defective. And I would like you in some capacity, whether you write this at the beginning or at the end, at the 10% significance level. Claim is incorrect. I'd like to point out that as I'm saying this, I'm actually using the context. I'm not just saying the claim is incorrect because at the 10% significance. I'm talking about what that claim means in the original question. I should be able to tell what the original question was about from your conclusion. Okay? All right, let's look at another example. All right. News programs suggest that the proportion of people who prefer to shower in the morning is greater than 40%. You take a random sample of 350 and find 122 of them prefer to shower in the morning. Okay. I literally just read a news story on this of like which one is better, and it said it depends on the person, so not a very informative news story whatsoever. Okay, so before we get much further, let's do this. What is our sample suggesting? about this 40%? Sample's saying roughly 35%, right? Okay, so the sample is suggesting the claim is wrong. Is everybody good? However, it's kind of hard to say because, well, 35% is not close to 40%. It's not like super far away either. Remember when I was like that $14.52? Is that surprising for the cost of a candy bar? And we were all like, eh. That's where I would put this right now. Everybody good? Okay. So, and at the end here it says, is this convincing evidence that the people who shower, that the proportion who shower in the morning is different from 40%? So different from, are you guys with me that different from would be not equal to? Okay. So in this case, I would make my null hypothesis P equals 0.4, and I'm going to call that my claim. My alternative is P is not equal to 0.4. And in this case, I did not give you a level of significance. Whenever I don't give you a level of significance, use alpha equals 0.05. Okay? So from here, to sketch my sampling distribution, I'd like you to tell me that it's a Z distribution, and then in the way we know it's Z, again, is proportions automatically mean Z. Okay? Now, how much of my graph am I going to shade? I can figure that out from my significance level. This is my total shading of the graph. Okay? So 5%. Before I shade it, which side of my graph am I going to shade? Last one we shaded to the right because my alternative hypothesis was greater than. This is both, right? Because if P is not equal to 0.4, I'm saying P could be greater than, or I could say P is less than. I know I do that backwards. You guys get what I'm saying? So I'm going to shade both tails. We would call this a two-tailed test. That's what it's called.
Do they each, I forget, do they each get?
I'm shading a total of 5%.
Oh, okay, so they get 0.025. Sorry.
So now my rejection region has two sides to it. And I find it by doing inverse norm. And I find that this one's negative 1.96. What does that make the other one? Positive 1.96. All right. Next, we're going to calculate our test statistic. That's my formula to do so. So my p hat was 0.349.
Pardon the interruption. This is just a quick reminder for juniors. You do have a mandatory Bobcat Connections meeting today at lunch. Thank you. Also, if you're participating in the Bark Mid-Ohio Food Bank event today, you have to turn your permission slip in ASAP. Thank you.
Again, just typing that formula in. You guys, where is negative 1.4948? If I look at my picture up here, it is just outside the rejection region. Do we all agree that negative 1.94 is not smaller than negative 1.96? Okay, so we are going to fail to reject. And my reasoning is negative 1.94, the actual Z statistic I found, is not in the rejection region, or negative 1.948 is greater than negative 1.96. Okay? Because that would be the boundary I would compare it to. Yeah. Everybody good?
Just need a second.
Xander, I didn't hear you, sorry.
Sorry, just need a second.
Okay, so what does my conclusion look like? If I'm failing to reject, I'm going to say with 5% significance, it's reasonable to say the claim of 40% of people prefer to shower in the morning is true.
Pardon the interruption. If you are a student and you have parked out front of the school building, first of all, you're not supposed to park there. Second of all, you need to move your cars ASAP. You're parking people in.
Is that like an 8 on Miss Kelsey's anger meter?
No. That's pretty typical for her having to say the same thing 15 times in a school year.
That black one, that black one's not really much in here on our commissions. It's horrible. That's the last time you think you see that. You see the.
From Mrs. Berlin,
Yeah.
That's Tatum.
what year did Nico graduate?
That's Tatum.
It was a student in Nico's class, their senior.
Sorry.
Yeah.
Gotcha. I just looked like it.
Guys, I'm going to stop here.